Hi, I'm Melinda Rose.
And I'm Krista Zanoli.
And this is Light Matters for October 26, 2011. In this week's 5 Minutes to Enlightenment, handheld projection systems that interact, a tiny device converts laser beams to ultrafast pulses, and we bring you some of the week's top business stories.
A self-contained, full-color handheld projection system called Side by Side enables animated images from two of the devices to interact with each other on the same surface. Side by Side was developed by teams at Disney Research in Pittsburgh and Carnegie Mellon University and can be used to exchange contact information or even share data files. The handheld projectors are hybrid devices that emit both visible and infrared light. They also contain a camera for monitoring the projected images, a ranging sensor, and an inertial measurement unit. The infrared channel plays a key role in enabling interaction. It is used to project markers that help the system recognize when the images are moving or overlapping and to communicate information between the devices.
A device that converts continuous laser light into numerous ultra-short pulses and is small enough to fit on a computer chip may have applications in more advanced sensors, communication systems, and lab instruments. Dubbed a micro-ring resonator by its creators at Purdue and the National Institute of Standards and Technology, the device is about 80 microns in diameter and fabricated from silicon nitride. Infrared light originates from a common continuous wave laser, is directed into the microring by a waveguide, and undergoes nonlinear interaction while inside, generating a comb of new frequencies that is emitted out through another optical fiber. By precisely controlling these combs, the team hopes to create advanced optical sensors that detect and measure hazardous materials or pollutants. The comb technology also has potential for a generation of high-bandwidth electrical signals with possible applications in wireless communications and radar. It may also compete with mode-locked lasers because it can be made so small.
Rochester, New York-based Sydor Optics said it has completed the final stage in a $4.5 million investment that will allow it to produce flat glass optics in broader size ranges, tighter tolerances, and higher volumes. The investment included adding 18 jobs and buying 14 new P.R. Hoffman double-sided grinding and polishing machines, several Zygo and Trapel interferometers, a Haas mini mill, and a robotic arm, which provides the ability to bevel over 6,000 optics per month for a single project. Applications such as 3D movies, debris shields for high-energy lasers, and wafers for DNA sequencing are driving demand, Sydor said.
Third quarter 2011 year-over-year demand trends continue the strong pace set throughout the year, although sequential demand is mixed and outlook for fiscal 2011 for most is still quite strong. That's the bottom line according to a new survey of laser and optics companies by Longbow Research. There is uncertainty in 2012, particularly with regard to China and microelectronics markets, senior research analyst for industrial technology Mark Douglas said, but Longbow is increasing its near-term estimates for industrial laser makers such as Sydor and IPG Photonics, believing they will report better than expected earnings. In a recent survey of laser industry companies, the investment analyst found that demand is still strong, with 89% of contacts reporting stronger year-over-year demand. Demand in optics was split, with half the companies surveyed reporting they are down quarter-over-quarter and 50% reporting flat demand.
Advanced materials company Materion announced last week that it has acquired China-based optical thin film filters maker EIS Optics for $24 million. Materion said the deal gives it a manufacturing base from which to better serve its rapidly growing Asian optical coatings businesses. EIS Optics operates a 97,000 square foot plant in Shanghai and employs 350. The company makes glass processing, lithography, and optical subassemblies for the projection display, entertainment lighting, sensors, medical instruments, and gaming industries.
Before we go, a quick note on a story that continues to develop. We are following the floods in Thailand, and we'll have a report for you next week on their impact on the photonics industry.
We hope you'll share the link to this video or any episode of Light Matters with a friend or a colleague. You can do that simply by clicking on the icons at the bottom of this player.
We'd also love to hear from you. Please send your suggestions, questions, or comments to lightmatters@photonics.com. You can also follow Photonics Media on Facebook and Twitter.
Thanks for watching, because it's only 5 minutes to enlightenment.
I've been interested in science my whole life, and so I just sort of got involved in ceramics and glasses in undergraduate. And one of the main aspects of studying glass has always been the optical interaction. So that's basically how I got involved with it.
We are working on, like I said, the National Student Solar Spectrograph Competition, which is where undergraduate teams design, build, and use ground-based solar spectrographs. So they get $2,000 budget plus a free grading from Richardson Gradings to put their spectrograph together, and then they use it at the competition in Bozeman and analyze the solar spectrum from that, and then see what types of light are involved with the solar spectrum, and perhaps evaluate solar cell efficiency, or how much absorption is involved with the atmosphere. I'm on a team myself, so there's 4 of us. There's 2 computer engineers, a mechanical engineer, and myself, and we are getting started on building our spectrograph right now.